In the previous video, we talked about what happens when we electrolyze aqueous dilute sodium chloride. So now we move on to the case where it's aqueous concentrated sodium chloride. Again, as usual, we will assign the terminals of the batteries and the electrodes, and then we will jot down the ions that are present in the electrolyte. We have sodium chloride, Na+, Cl-, and since it's aqueous state, there will be hydrogen ions and hydroxide ions from water. And then we talk about the cathode. At the cathode, we have sodium plus and hydrogen plus. Okay. We know that sodium plus is very stable. It comes from a very reactive metal. It will be hydrogen that will be preferentially discharged. So this is no different from the aqueous dilute case at the cathode. Hydrogen will become hydrogen gas. It is at the anode that things are different. At the anode, we have competing ions of hydroxides and chlorides. Okay. And when we talk about the anode, we have to be careful whether it's concentrated or aqueous, especially when halides are involved. When it's dilute, chlorides will be discharged in preference. When it's dilute, hydroxides will be discharged in preference. But when it's concentrated, it will be the chlorides that will be discharged. So in this case, chlorides will be discharged. We will form chlorine gas. And balancing out the charges, we have 2 electrons on the right side. So that's the difference between aqueous dilute and aqueous concentrated. It happens at the anode. For dilute case, we will get hydroxides discharged as oxygen. For concentrated case, we will get chlorides discharged as chlorine gas. What observations can we see at the electrodes? At the cathode, we will see hydrogen, or rather we will see effervescence of the gas, and if we were to test for the gas, it will extinguish a lighted splint with a pop sound. At the anode, if we were to collect the chlorine gas and test for it, within your syllabus, we test for chlorine gas using moist blue litmus paper. The litmus paper will turn red and then it will bleach. Okay, it will turn white. What is the ratio for hydrogen gas versus a chlorine gas? We can see that the electrons are the same, so we do not need to multiply by any factor. We can compare directly now. So 1 mole of hydrogen collected, we will also at the same time collect 1 mole of chlorine gas. Okay, so the volumes will be the same, ignoring the issues of chlorine, some of the chlorine dissolving in the solution. What happens to the electrolyte? Okay. At the cathode, we are removing H+. At the anode, we are removing chlorides. So you can see that we remove H+, there will be an imbalance where hydroxide ions will be more concentrated than H+ ions. So the pH in this case will be increasing. It will become less acidic. It will become more alkaline. And you realize that we actually get sodium hydroxide as a product of your electrolyte. So there are actually 3 useful things we can get from this electrolysis: hydrogen gas, chlorine gas, and sodium hydroxide. Some questions they might ask you, why do we need to make sure there's a separate membrane to separate the chlorine from the electrolyte? Okay, the additional info that you will need is the chlorine will react with sodium hydroxide, so you need a membrane to actually prevent them from happening, or prevent them from reacting.